My name is Abbas Saboowala. I'm the product manager with our data acquisition suite of products that also includes our PI interfaces and PI connectors. Co-presenting with me today is, as you can see on the slide, Chris Fells, my counterpart with our data ingestion suite of products. But there are three names that you don't see up there, and they are our three partners who will be coming up on stage after I present and giving some wonderful demos and talking about the wonderful things they've done with our latest technology. So stay glued in your seats, chain yourself to the chairs, whatever. So moving on, just to set the stage for this presentation. In the last couple of days, I'm hoping that most of you have attended some kind of a talk which goes into details about pervasive data collection or data connectivity, data collection, and you have a good idea of the suite of products that OSIsoft offers for your data ingress and data acquisition needs. So I'm hoping as part of this presentation, I don't have to give you a 50,000 feet high view, but instead focus on the small nitty-gritty stuff that we've done with our products to improve its performance significantly and bring to market certain capabilities which have been highly requested by our customers. So moving along, I'll briefly speak to this slide. I'm hoping most of you have seen this slide by now as part of some presentation. But what a pervasive data collection strategy is offering our users and customers with a suite of products that covers all their data acquisition needs, starting with OSIsoft developed PI interfaces and PI connectors, the edge data store, which serves the purpose of a mini historian sitting at the edge, which allows you to aggregate, collect, and visualize data, and our OSIsoft messaging format technology, which allows you to create your custom applications for your very specific needs and requirements. So when it comes to data acquisition solutions that OSIsoft provides that you can use out of the box, plug and play, and start collecting data instantly, there are two types of technologies. One is PI interfaces, and the second one is PI connectors. Within PI connectors, we have different flavors of PI connectors. So what you see on the screen is our most recent offering of a connector, the way it's architected. And what you're looking at is a data source and two pieces. One is a connector piece, one is a relay piece. And the connector piece collects data from the data source, passes it on to the relay, which can then fan it to the destination PI server of your choice. What you don't see out here in this diagram is a third component called Data Collection Manager, which is a centralized admin app which lets you manage and administer all your connectors under this one roof. And I'll be showing you that in the demo, so hold on tight. We'll get to that, and you'll get a good look and feel of what that product looks like. So diving right in, as I said, that was the 50,000 feet view. Now let's go to sub-zero and look at some of the stuff that we've done to improve the performance and functionality across all our connectors. And a lot of the work that's represented here is done in an underlying framework on top of which all the connectors are built. So a lot of the connectors can leverage the work that is displayed here. So diving right into the first one, the support for larger data sets. As a product manager, it is my role to understand that the features and functionalities, the improvements that we are doing with our products resonate with a much larger audience. So one must be questioning, why would you do something like this? And the short and sweet answer is that our customers, the majority of our users, customers, existing and prospective, are still supporting a lot of the traditional data sources like your DCSs, your SCADAs, your process historians, and other kinds of centralized servers. And the kind of information these systems surface is massive. It surfaces several hundreds of thousands, at times millions of attributes. So the ability to be able to handle all this information in an intuitive and convenient fashion is very important. So what have we done? The before and after. I would request you to look at the table at the bottom first. And what you see out here is some of the tests we had done with a 2.2.x version of a framework, which was the older version. And the things listed in the leftmost column are some of the actions that you can do in the data collection manager, where you can click on certain nodes, you can expand the root element, you can expand the child element, you can apply certain selection rules. If you compare the performance between the 2.2 version and the 2.3 version, it's night and day. It's magnitude times better. And in certain cases, there's not even a comparison. It's just so significantly improved. If I was to draw your attention to the table at the top, we expanded the scope of a test to test for 1 million assets, which had 10 properties each, which makes it a total of 10 million properties. And some of the tests we ran with that, as you can see with our older framework version, it wouldn't even handle it. It just would throw an out-of-memory exception. And those tests were run on a machine with 32 gigs. So it wasn't like a lightweight machine. It was a pretty mean, chunky machine, and it just couldn't handle it. And with our latest offering of the framework, that can be done in less than half a minute. So some of the things out there, the work that has been put in to handle these larger data sets is absolutely awesome. And one of the connectors that comes to mind that we are planning to bring to market fairly soon, it's in beta right now, is our Pi connector for Honeywell PhD. And a Honeywell PhD system, for those of you who are not familiar with it, it's a process historian, which it could have potentially several hundreds of thousands of data items in there. So when you're trying to pull data from these kind of systems, you need these kind of improvements to be able to service that amount of data. So jumping right into a demo, and this is where I'll be spending the majority of my time during this talk, I'll dive right in. And even though that might look like a scene from The Matrix, it's not. I was told the video would play automatically, but it's not, so. All right. What do I do here? OK. All right. So what you're looking at on your screen out here is our data collection manager. And I'll be using our data collection manager to demonstrate the ability to control the tag names and the tags that you write to. So those kind of processes, with the current connectors, cannot be controlled. They're automated. With our newest offering, we are giving the users some control to control the tag naming conventions they want and the tags they want to write to. So what you're looking at in the leftmost column, just to give you the lay of the land, is the data source, which in this case is my computer. The column next to it is a custom connector that was built to read the process monitoring information from my computer. Next to it is a relay, which essentially sends data to a collective, so there are 2 Pi servers out there. Before I proceed, I think it's fair to give you guys a very brief explanation of how the tag creation and tag naming works in the connector right now. The connector queries the data source and identifies these strings and metadata information, which are unique strings. So it takes that string name, which it identifies, and goes ahead and creates that string name as a tag in your Pi server. And you don't have a lot of options to control that. So having said that, what I'm going to do next is I'll go ahead and hit the Select Data button. And that should take me to the screen, which essentially shows you a discovered view of every process that the connector found on my computer. And if you drill down, you can look at the attributes associated with that process. So at this point, I'll just go randomly select a few of these processes that I want to start collecting data for, monitoring data for. And I'll go hit Next. And now what you see is the list of items that, if you were to proceed, it would create these number of tags, which are about like 15, 20 of them. And it would have the names as they are shown there. As you can see at the top of your screen, there are 2 options, automatic and manual. If you were to select manual, as I said, it would just stick with these names. You have to do no configuration, nothing. You just hit Next, and your work's done. However, if you had a very specific naming convention that you wanted to feed in your tags, this is a chance to actually key that in. So when you select the manual button, radio button, you see there's a custom name column out there, and what you can do is the view, what you see out here can be exported to a CSV file. So that's what I'm going to do next. I'm going to hit the export button, and that is going to export this list of tags in a CSV file. And once the CSV file pulls up, you will see there are 5 columns in there. And I would request you do not worry about a couple of the columns, especially the ones that are called data type and category. Do not worry about it. The description actually gives you a good description of what that tag item is. The name is the name which it's recognized as a unique string name. The custom name column is the one where you would actually go in and key in your custom name. So we'll get to that in a second, where the custom name I'm entering is custom-02 or 00. And using the wonderful powers of Excel, you can populate the name in every single row out there. And talking about Excel, the reason we decided to go with Excel is there are a couple of good reasons. One is everyone's so familiar working with CSV files, and the formulas it offers you, the advanced functions it offers you, it's unmatched. So CSV, exporting this to a CSV and working with a CSV instead of a JSON file or something made perfect sense. The second reason being that a lot of our customers use PyTag Builder, which is a built-in plugin into Excel. And they're very familiar with the lay of land, how PyTag Builder works. So that's the reason we stuck with Excel. What I did while I was talking was I went ahead and saved that configuration. And as you can see, some of the tags I've defined a custom name, but for some of them I have not. I just stuck with the default names. And what you see out here now is it's asking you to to choose a destination, and that's a tooltip. So which means that's what I've gone and done. I've chosen a destination where I want these tags to be created, and soon you will see there's a check names button next to the destination. The moment I hit that button, I want you to see what happens. You see right now it's saying not found, not known, right? Or not checked. The moment I hit that button, voila. So it's done some validation, and it's checked on the PyServer, the data archive that you selected, and gone and looked for those tag names. And it's come back and telling you you're good. All these tags that you're creating, none of these tags exist on the PyServer. So you have the liberty of going ahead and creating these tags on the PyServer. Now, just for fun's sake, what I'm doing is I'm changing the name of a couple of those tags to AA and B. And what you'll see is automatically through the validation, it's identifying that these tags exist on the PyServer. So could you still go ahead and create them? Yes, but instead of creating a new tag, it's going to use an existing tag, and that's exactly what it's telling you. And that action column, the idea behind the action column was to surface this kind of information to the user, so it's very easy for them to identify what's going to happen if they were to proceed with the tag creation. There's a slight pause here, so I'll refrain from putting in any fillers. I should have edited the video better. All right. Cool. So the other option you have is you can hit that drop down, and you can filter the list as per the different actions. So right now I've filtered the list per only the tags which are existing. Now what I'm doing is I'm going in and keying in an illegal tag name. So as you can see again, the validation checks that for you and tells you, hey, this is an illegal tag. You cannot create this. And again, I can go ahead and sort by that illegal tag and easily identify which illegal tags am I working with. So going back, I'm going back to the way things were, where I'm not using any existing tags. I'm creating a brand new set of tags. And once I hit next, oh, one more thing. These rules apply to every individual Pi server. So if you're working with a collective, if you want a different set of rules to apply to the secondary member, you very well could set those rules. So you have the provision to control how these tag names are controlled. All right. So what you're seeing on this screen, it's basically just a review before you finalize your check-in. And it's telling you this is exactly what's going to happen. The moment I hit next, all right, the tags are created. And how do I know that? Is because if I was to go through this process again, where if I hit select data, and land back on that same page where I'd initially done the configuration. Now if I check names, look at the action column. It says use existing, which means these tags were not created just a couple of minutes back. Now it shows use existing. You can also go ahead and quickly check in the Pi System Explorer. And I'm looking at that very first tag, which is the processor type. If I was to drill down in the AF hierarchy and find that tag in the hierarchy, all right. OK. So as you can see, it's stuck with the default name. It's not applied any customization on the name. If I was to look at one of the custom names, which is the custom-02, and drill down again in the AF hierarchy and track that, all right, there you go. So all in all, this works extremely well if you want to control the processes pertaining to the tag names you want to give or to which tags you want to continue writing data to without the connector creating a new set of tags. This is awesome. All right. So moving on, I'm going to talk about 3 connectors. The first connector is Pi connector for OPC UA. And the reason I want to talk about this connector is because it's a very widely adopted protocol for industrial automation. And a lot of customers are moving from OPC DA to OPC UA. That move is gradually happening. And we've been working quite a bit with this connector. And what we've done in the last few months is we've gone through OPC Foundation and got this connector certified, which means this connector has been tested for compatibility across a large number of vendors, and it works absolutely fine. We also have incorporated support for something called tag-only mode. A lot of our customers came back to us, and they were like, we do not need metadata context. We have our own AF model that we built. We don't want the connector to be creating it. And we honored that request, and we've supported tag-only mode, where you can get out of creating an AF model if you didn't want to. And there are some other significantly improved benefits with this connector. The next one I'm going to talk about is Pi connector for Wonderware Historian, which is very prominent in the oil and gas industry, but it's gaining a lot of popularity in other industries as well. And we've done a number of things, but the key takeaway is we've made a lot of changes pertaining to how the store and forward logic is handled with the connector, and also pertaining to instrumentation. We've given the customer a lot of instrumentation information, which they were missing back in the day. And last but not the least, Pi connector for MQTT Sparkplug. This is a very popular one. I've had a lot of people come up to me, talk to me. I've had emails around this connector. One thing to clarify in regards to this connector is this connector supports only the Sparkplug B specification, which means that for anyone who's worked with MQTT, MQTT is a transport protocol, just like HTTP. The payload definition is done using the Sparkplug B format. So if you are sending a payload with MQTT which does not match the Sparkplug B format, the connector will not be able to understand it. However, if your payload is looking something like a JSON schema, There are some converters out there in the market which could convert this JSON schema to protobuf, which Sparkplug B uses, and you can continue using a connector. So with that, I'll leave you with the slide. We have a lot of active development work going on with the connectors. The ones which are marked as beta, they are currently in beta. So if any of these fit with your needs, please come speak with me, and I'll be happy to discuss this further and potentially get a beta testing program going for you. And I'm going to leave with the slide. This is our connectivity roadmap. A lot of what I spoke about in the left-hand column, the leftmost column, is work in progress. Some of it is done, but it's very much a work in progress, and we are actively working on it. What you see in the middle column is what we are considering next. Things like multi-platform compatibility, making a connector lightweight and highly performant, and supporting a connectivity strategy which allows you to write data to the edge, to the Pi server, to the cloud services, OSIsoft cloud services. That's all in consideration as the next step. And as a long-term vision step, we are hoping that eventually we can get to a stage where we can support the remote operations monitoring scenario. A lot of the assets are sitting at the edge, and customers are, with the expanding technology, and you'll hear about it in a few minutes from our partners as well, they are able to get insights into these remote assets. And that's what you're hoping to get to, put a foolproof strategy and solution in place to support these kind of scenarios. And the manageability and deployment aspect across the organization, which makes a person, a Pi admin, or a process operator, or a process engineer's life much more easier when working with multiple kinds of connectivity solutions. And with that, I invite Chris Phelps to come up on stage and tell us more about edge technologies. Thank you.
Thanks, Abbas. All right, good afternoon, everybody. Thanks for coming this last day of Pi World. So again, my name is Chris Phelps. I work on our product team. I have responsibility for kind of looking forward to what we're doing around our data connectivity needs. So as Abbas mentioned, we'll talk quickly about our edge technologies. And as Abbas mentioned, today, the intent of today was to do a little deeper dive on all the product talks today. So I'm going to implement my deeper dive by having some partners come on stage and show us how they're using these edge technologies. But first, a little grounding. Abbas showed us this slide. This is really what we call our pervasive data collection initiative. And really the intent is, OSIsoft, we want to say no matter where your operational data resides, we want to have products and technologies that allow you to collect that, store it, get it to its destination, either a Pi server or OSIsoft cloud services. And why there's kind of 4 capabilities, 2 products, 2 technologies, is we expect data connectivity needs are going to change. As Abbas showed, interfaces and connectors really targeted for those in-plant systems. And we know in this new world of IoT and all the technology that IoT is bringing, a lot of data connectivity needs kind of outside that traditional OSIsoft architecture, which is connecting to these automation systems. So we want to be able to deliver connectivity needs outside of our traditional data sources. So what I'm going to focus on today is the edge data store. And again, part of the reason why there's many options is there's many edges, right? Depending on what industry you serve, what kind of assets you have, we expect there to be lots of different things that are generating data, again, typically outside the walls of your plant. Here's a few examples. The partners that I bring on stage are going to show you how they've implemented our edge data store on several of these examples. So again, a little bit deeper dive on edge data store. If you run our product talk on Tuesday, I didn't go into this level of detail. But we're building a new product built from scratch called the Edge Data Store. It's really meant to go places where the Pi server isn't a good fit. And by that, I mean maybe because you need a Linux operating system, you need a hardened device. It's running on some remote asset where there aren't people around, so you don't have this idea of a Pi admin. So many reasons why Edge Data Store is a good fit. So imagine cases where you have real-time connectivity needs. You need to persist that data at the edge, maybe to serve a local operator, to have ways to do visualization locally. So we want to build this product knowing that there are not people around typically to administer this. So it needs to be hard and robust. When the lights go dim, it needs to wake back up when the lights are on and just keep on trucking. We want to also support Windows and Linux operating systems. So again, give you that flexibility on the hardware side to meet the needs for these typically remote environments. So quickly, what that looks like under the covers. For the first release, we're really focusing on a couple of capabilities, different ways to get data in. So we're going to support OSIsoft message format. This Edge Data Store has a native API, so if you prefer to use that. Also, it'll have built-in connectivity to Modbus devices and OPC UA servers. As Abbas mentioned, OPC UA is a really up-and-coming connectivity platform for us today. Of course, because it's a historian, a way to persist the data locally, so there's a storage capability, and then an inherent way to upload that data to a Pi server or to OSIsoft Cloud Services, an administration surface as well, and then again, as I mentioned, the REST APIs. So with that, what I'd like to do, introduce our first partner. We have an early adopter program for our Edge Data Store. These three partners that I bring to stage are early adopters, so they're going to tell you how they're using the Edge Data Store and this new connectivity to help solve customer problems. So with that, Mikhail Koloskov from IPCOS will be our first demonstration.
Thanks, Chris. Good afternoon, everyone. Digital transformation becomes easier if you have money and if you have relevant data. But if you have both, what if you don't have money? In IPCOS, we have a lot of experience working with the assets or oil fields where you don't have any data for your remote assets. And there are good reasons for that, because there is no way to justify instrumentation, connectivity to SCADA, proper sensors if your well or asset produce just a few barrels in oil. This is oil and gas experience. So what you would do, and luckily there is a new solution available which we have developed together with OSIsoft Edge Data Store, based on Edge Data Store, and I'm going to do my demo today about this. Thanks. IPCOS is the system integrator. We work globally with mainly oil and gas and energy industries, focusing on the production surveillance, production optimization, integrated forecasting, generally process excellence. So we have a long history with OSIsoft implementing solutions, and we are a partner of OSIsoft. Here, we started the journey with OSIsoft last year with Chris Feltz, with developing the solutions based on the Edge Data Store. And the solution I'm going to show you today is specifically about beam pump application, which is very common across all the world, in the United States, in Europe and Middle East. And you would be surprised how many of the beam pumps are there, so there's thousands and thousands. And there are a lot of people driving around and collecting the manual data, checking if the pump is running or not, etc. So we see the increasing demand for low-chip solutions, low-cost solutions, compared to the traditional automation. And there are good reasons for that also. So the IoT architecture could bring significantly automation costs down. Then, especially in the beam pump case, for instance, you would be able to use the high-frequency data processor and derive information which is required to diagnose your pump. Also, these solutions could be scalable and modular. So I'm going to focus today on showing you three components of the solution that we have developed. We call it beam pump application. And during the demo, you will see three components, three screens. First, we will focus on the Edge Analytics, which is running on the Edge device very close to the well. It could run on the device like this. So it's an Edge gateway. It could be any gateway, Raspberry Pi, ARM, Intel-based, any cost, so depending on your use case. Then I will show you how the data is visible that we collect in the traditional Pi system. I will use Pi Vision for that to illustrate the data that we have collected to diagnose the pump. And finally, we'll look also into how the data could be visible in the Edge Data Store itself. That is the first screen that we will see. So what we'll do there, we will capture the real-time frequency data, the power, by using the power meter connected to the edge device running the edge data store and analytics. We process this data. We capture the data 10 times per second with a 10 hertz. We process this data. We derive information which is sufficient to diagnose the pump, to predict failures, etc., to predict issues, and also to send this data to Pi system. It could be either Pi system in premises, in the cloud, or OSIsoft cloud services. So for illustration, in the demo, we have also included the temperature sensors, which connected to the edge data store, and this information also goes to the cloud. So this is just to demonstrate that we don't need to wait until pump will fail. We just could use the temperature sensor. So I recorded this demo just before setting up the booth. We have exactly the same demo at the booth. So let's have a look. And while we do the presentation, you could see that let's see. Let's run the video.
Yeah, it's not running.
Okay. Okay, so we see the first screen. So this is the web interface built on top of the analytics. So you could see that on the left side, we derive parameters to reconstruct the diagnostic dynagraph of the beam pump. On the right side, you could see that there are some parameters, and below the screen, you could see the real-time data that we're capturing and processing in real time. So every stroke, which is typically from 5 to 10 seconds, we collect the data, we derive the key parameters, the details, the KPIs, how the pump is behaving, and we transfer this to the Pi server, and we visualize it in a Pi Vision. So as you could see here on the right, we visualize these parameters. The same table that is available on Edge, you could see that on the left bottom. And also you could see the temperature sensor, which is connected. So, and you could do this standard capabilities. You could scroll the data, zoom in, zoom out, have a history. So this flows in real time from the Edge device to the Pi server and could be visualized. So next, you could see this same data, which we visualized here and which we persist in the Pi server. Also, you could see that in the interface of the edge data store. And this edge data store running on the small device that I'm showing here. And you could view the data, you could set up. So here I've just said that I've recorded it just before the demo. I'm selecting the dates, and I just viewed my stream. So I could see the same temperature values, 26 Celsius, that I have recorded. The interesting enough is that this is very simple setup that we created for the booth in Barcelona. And immediately and surprisingly, you could get very interesting data insights that you would not collect that before. For instance, by just playing with a demo at the booth, we have discovered that the temperature went up during the night hours. So the booth was running, nobody was there, that the organizers or the venue was switching off the air conditioning. As you could see here at 6 o'clock in the morning, they switch on the air conditioning and the temperature goes down to 90 degrees as it's usual. So we didn't know that while we were during the day, but at night we could see that. So this is a very simple example where immediately by capturing the data, you could see unexpected data insights. So finally, let me come back and to my original point, so that where's the money, how you could get that. Actually, there are two things. The data collection and the data analytics on the edge allows you to reduce your downtimes, to avoid manual inspection of your remote assets, and also to plan properly and to increase the production. We see the demanding cases now, and we are planning to do a few pilots on this technology in a few fields in Europe.
All right, thank you, Mikhail. So yeah, a great example of a partner. Great example of a partner using our data infrastructure to provide additional value, as you saw in Mikhail's demo, doing local edge analytics, uploading that data to a Pi system and taking full advantage of then the capabilities of the Pi system, and in this case, via AF. Next, I'd like to bring up Martin Handels from Rolos, who again will be our second demonstration of his use of the Edge Data Store in his application. Martin, thank you.
Thanks, Chris. Let's see if this video works. I'm going to start with a video, if you're okay with that. Ah, it works. Lo and behold. Anybody guess what we're looking at? Where are we? All right. Huh? Any guesses? Yeah. It's an oil rig. It's the drill floor. It's still one of the most dangerous places to work on an offshore drilling rig. And what you're looking at here is, this is true artificial intelligence. This is one of the systems we built for our clients. It has 16 or 17 cameras on top of the drill floor. And the cameras have been fed into a deep learning algorithm. And we are now able to detect the location of people. So we can create an automated red zone management system. That means we have a driller, he has a user interface, he can go into a certain operation, he can press a button, and that zone is then a no-go area. It's really hard to get that going with barriers because it's a dynamic workplace. People need to be in certain situations during certain operations. It's really hard to keep track where everybody is. So this system does that. One thing we do is we track people. So the video on the left for you guys, you just see the algorithm picking up the people, and we know where their location is. On the right-hand side, you also see us detect the equipment. We can detect which type of equipment is and where the location of that equipment is based on video images. Now, video images actually brings you so far. So the best way is to combine video with the time series data that's behind the equipment that's being operated by the OPC or SCADA data. So what we use the Edge Data Store for is we don't want to overload our backend with storing time series data. We deal with video data. And I wish I could say that OSIsoft is changing its business model. I'm going into video feeds, but that's some fake news there. So what we do is we can deploy a full Pi server. One part of our company does this type of technology. The other part helps OSIsoft customers actually build analytic solutions on top of Pi. So we figured if we're pushing out a product towards our clients, we should also eat our own dog food and put it in one of our own products. Now, a Pi server is overkill. But then Chris came along with this amazing, lightweight, deployable system called the Edge Data Store. And for us, we started tinkering around with it. And at some point, my product team just gets really bored of me because I kind of go like, in the US, you say, you put a little bit of ranch on it. I just say, let's put EDS on it. EDS and Docker are my two go-to words when I talk about products. So that's an architecture picture. So what we do is we take the equipment data. We're also testing one of the beta connectors that actually fully Docker deployable as well for the Modbus. We get the data out from the equipment manufacturer on Modbus. We ourselves feed our backend data, so position of people and where they've been and which areas they've been most. We feed that in through OMF. We have a backend that speaks MQTT, but we get it into EDS by converting that into OMF. Then we feed it out to a Pi server in cloud, and then we have the option to stream it out to one of our visualizations or feed it further into our data science platform. So that gives us a UI that can be run against EDS, we can run it against Pi, and we can run it against OCS. And for me, that makes it a lot easier in deployment and keeping up code bases. For me, the main thing with EDS is just it's lightning fast. You have it up in 5 minutes, and if you configure the data going in, it's up there. So for me, I love it, and I really think for Edge, it's the way to go and work with it. So that's me. Thank you for your attention.
Thank you, Martine. All right, thank you, Martine. Again, another great example of a place, as Martine said, PyServer's not a good fit, a rough, rugged environment where running a Windows server on that rig wasn't a good option for them, so Edge Data Store run on a small, ruggedized Linux device was a great fit. So last for our demo, I'm going to welcome to the stage Michael Saucier and Reese Kirk from Transpara. They're going to give us yet another awesome demo to exemplify their use of the Edge Data Store.
Thanks a lot, Chris. Okay, well, I'm not going to read this slide to you, but I had to send something in that represented, let's say, some of the opportunities that exist at the edge. And I'm supposed to use this. Okay. So just to cover a couple of industries, retail, human, tracking humans like you do, that's a great demo, by the way, of keeping people safe. I really like that. But every industry is now realizing that data at the edge has an enormous amount of value in it. And it's stuck at the edge until you can get it into some place that you can do big data analysis on and come up with insight into what's happening at the edge. It doesn't matter whether in banking or retail or chemicals or pharmaceuticals. All these industries have this in common. So I think that we've got really not too many slides, right? Here's our architecture. So let's see, go ahead and let's put the first one up here. So we've got something called the Transpara Smart Edge software. It runs on top of EDS, and it lives in a small device. It could live in a Raspberry Pi, like one we've got up here. It could actually live inside a Pocket Beagle that actually runs EDS already. So there's almost no limit to the size of device that you can tap and get the value out of its data. So the first thing that we're going to show live is we're going to turn on a cold device, have it power up. We're going to spin up EDS in 1 minute, and it's going to identify itself to the cloud. The cloud's going to receive this ping from the edge, and the cloud's going to come back and provision the device. That's going to put configuration information into the right place on the EDS device, and then it's going to start running according to the instructions given to it by our central server. Next one. So then EDS does its job. It starts collecting data, and if you lose connectivity, now it may not be in this exact build, but if you lose connectivity, the backfill mechanism that's in the roadmap that will certainly be in the GA product will come back and fill up the cloud with the stuff that you've been collecting all along while you're offline. It's especially important to people with assets that might go underground. Mining operations, for example. If you've got things that lose connectivity, or you're in spotty coverage area, or you've got a cell phone that you want to spin up a few times a day, upload the data from some remote solar-powered faraway place. So the idea of collecting the data and keeping it at the edge until you have a chance to push it up into some more permanent storage is really powerful. So the final thing that happens is we push the data to OSIsoft Cloud Services. The visual KPI components in the center read that data and that metadata coming from the edge, and we automatically identify KPIs, metrics, hierarchy, navigation, trends that ought to be associated with that class of device, and we deploy those to the visual KPI server programmatically. And then finally, there's a human, that's going to be us, and if all goes according to plan, within something like a minute or a minute 20 seconds, we can plug a cold device in, have it spin up, identify, and show up on the screen in our software ready to consume by a human. So Reese, if you would like to start the demo, let's remember, we don't have a video, so he's going to have to press the go button. All right. So what have we got here? We've started with a handful of devices. There's a device count in the top, 3 different device types. We've got 2 EDS objects running in Windows boxes. We've got 2 EDS instances running on a Raspberry Pi. And we're going to plug in a 5th device, and it's going to self-identify and just pop up on the screen. So let's give it some power. So it's going to go through its power on sequence. It's going to auto start all the services. EDS will come up. The transparent Smart Edge software will come up on top of that and start communicating. Basically, ET is phoning home, asking, what should I do? So over the course of the next minute or so, that communication handshake takes place, and we instantiate a bunch of new streams in OCS. Those streams are then fed into the Transpera Visual KPI server, and all the objects around that are created programmatically, and then they'll pop up on the screen. So I think we should start a timer. Oh, it says 0. Are we out of time already? Well, the big finish is coming, though, so let's just hang out here. This is the part where, okay, I'm going to pause the video, and we're going to wait for the bits to spin this stuff up. But now, remember the path it's taking. The device has to identify, has to connect to the endpoint and say, you know, I'm alive. The endpoint has to say, well, what's your class ID so I can do something about that? We look it up in a database. Oh, you're a pump. You're a motor control center. You're whatever. You're a gas chromatograph. This is the things I need from you. The device came up. The device count went to 5. The device located itself on the map, so you can see it's connected and showing on the map, but it doesn't get any data yet. It's building the tags. And then we'll see the data that was collected by EDS will eventually show up in OCS, which is the source for this screen. So this is a web server product called Visual KPI. It's in front of OCS as the data store. You know, 5 seconds never seems like a long time until you have to hold your breath. Was it like this in Barcelona? Was it? I can't remember. Because in Barcelona, we have the KPIs are created now in San Francisco. And they should be showing up in the trend lines here shortly. There you go. Yeah. Okay, so now the new device that was provisioned is this EDS device 1. It joins its brothers 2 and 3, you know, some very clever naming. But now the data stream is in the blue line inside the state of that data. So the color represents whether it's in good, high, low, whatever. And so now what we've got is the big punchline of a self-provisioning EDS-based edge device that could be any IoT device. It could be on a big Caterpillar machine. It could be on a boring machine underground. It could be on a head of lettuce, or maybe even a vertically grown California marijuana factory. So it could be almost anything. That's it for us.
All right. Thank you. I'll take this. So thanks, Michael. Sorry, we're a couple minutes late, but that was, it's hard to tell, but that was an impressive demo. From 0, he plugged in his device, it phoned home, it got its configuration, pushed it back down from the cloud via the Wi-Fi here in the conference room, and then Edge Data Store started collecting from the sensors on board the Raspberry Pi. Very, very impressive in that maybe it took a minute longer than we expected, but within 3 minutes, all that happened. So, you know, again, think about these places where Pi servers may be not a good fit. This is a great example. Imagine spinning up a Pi system and getting it collecting data and then sending data to the cloud in 3 minutes. Very impressive. So there's Michael, his contact information. Unfortunately, I don't have Reese's info, but we'll get it to you if you need it. So again, to wrap up, and again, I appreciate we're late, so thanks for sticking around. I won't get into this, but the roadmap, like Abbas showed, connectivity roadmap, similar roadmap for Edge Data Store. So what's in the developing now, that's what you saw demoed here. If you like what you saw and you have, hey, I could use that, or I have a scenario similar to what you saw here, you could extrapolate to your own scenario, let me know. We're always looking for folks to join our early adopter program. The intent of having an Edge Data Store out for general availability for the next Pi World, so we're getting very close. As you saw, we have quite a mature product already, and then considering next and then the future. So unfortunately, we're at the end of the day, but if you're really excited about these things, you have 2 talks still yet to go to at 3:30. We have one of our partners that's built OMF, which was some of the underlying technology that you saw today, into their device. And then also our development team is doing a deeper dive on the Edge Data Store itself. And then here's you'll get these slides, but there's content around the Edge Data Store if you're interested. So with that, thank you. If you have questions, comments, send them to feedback@osisoft.com. That's where we're tracking product feature requests. So thank you for your time. This is Abbas and my contact information. Unfortunately, we're out of time for questions, but I'm sure Abbas, Mikhail, Martine, Reese, and Michael will hang around if you have questions. So thank you very much. Have a good rest of the show.